Hey guys, in this presentation, we're just going to try to quickly talk about ratios, rates, and unit rates, and how they're similar and how they are different. So here you can see a definition of rates. You guys can pause it and read this more if you want, but a ratio shows the relative size of two or more like values. There are several ways to show this, part to part to whole. Comparisons are here. So you can say part to part, there are 4 green to 6 purple. Or you can say there's 4 green out of 10 total pieces. So 4 to 6, 4 to 6, 4:6, or 4/6 are various ways to write the ratios. And ratios simplify just like fractions. Like in the previous thing, you can only use out of if the second number represents the whole. So, but right here, I could say 4 out of 10 because it is 4 pieces out of 10 total. Here, I could not use out of because it isn't a comparison of a part to a whole. So here, you could say 4 to 6. You could write it as a fraction still and say 4/6, but you cannot say out of for that one. So here are some examples with my bats. So there are 2 bats, 4 trapezoids, 2 hexagons. So we can say there are 2 out of 10 are hexagons. Where we get that is there are 10 total shapes here. 2 of those are hexagons out of the 10, and that would simplify to be 1 out of 5. Another way we could write it is 1/5 or 1:5. Those are other things. Or we could say 1 to 5. Same thing down here with this one. This is a part-to-part comparison because I am comparing hexagons to triangles. So that is 2 to 4 or 1 to 2. Notice that I'm reading this colon as the word 2. I cannot read that colon as the word out of if it's a part-to-part comparison. I could up here. I could read it as out of. So here's some examples to quickly go over. Elizabeth made 21 cups of coffee from 6 ounces of coffee beans. What is the ratio of coffee beans to cups of coffee? So this is going to start as 6/21. Both of those can be divided by 3. So that is 2/7. So let's take our little magic wand here and see if we can determine if our answer was right. So none of these have the bunny rabbit. This top one has the bunny rabbit, and it is 2 to 7. Now I can't say out of here because we don't really have a comparison to a total. But we did put the 6 first because this asked for coffee beans. Coffee beans to cups. That's the only thing you have to pay attention to in ratios. Is you're trying to see about that comparison. Let's move on to the next page. So this one right here is Raven is making soup. The recipe calls for 6 carrots to 15 tomatoes. What is the ratio of carrots to tomatoes? So that starts as 6 to 15. And then you can see here that simplifies to 2 to 5. That is where our little giraffe is hiding for that one. Again, these do not have units attached to the numerator and denominator or the left side, right side. That's why it's just considered a ratio. So rates. A rate is a special ratio in which the two terms are in different units. Here we have units attached to this. So here we have 6 books, that's the unit, for $48. And in this case, dollars is the unit. And generally speaking, if we're talking about dollars and quantity, we're going to put dollars on top and quantity on bottom. And when we get to unit rates in just a second, it'll make more sense why that's important. Here we have 76 miles in 2 hours. Again, 76 miles has a unit attached to it, and 2 hours has a unit attached to it. Rates start comparing different types of things. In the previous examples that I just called ratios, it was shapes compared to shapes. But here I'm comparing money to books, or miles to hours, or again, money for cups. So that means that I have to make sure that I have the units for these. So again, a rate is a special type of ratio that introduces different types of units for that. So here I have the phrase 200 miles per 5 hours, or I could say 200 miles in 5 hours. So that would be 200 miles over 5 hours if I want to write it as a rate. This sentence is a rate, but for our purposes, we want to write the rate as a ratio using the fraction bar. And again, it's just a special ratio. So here are some crazy writings all over the page, but it says, what is a unit rate? The most important thing about a unit rate is the rate for 1 unit of a given quantity. So in this case, we're going to go back to that $48 for 6 books. This is my rate. My unit rate is going to be $8 for 1 book. So we're going to divide both the numerator and the denominator by 6. That's how we got there. 48 divided by 6 is 8. 6 divided by 6 is 1. So that means the cost per book was $8 per book for that. Here, if I was traveling at a rate of 76 miles in 2 hours, that means that's my rate. I'm going 38 miles in 1 hour. This is my unit rate. And up here's for my cups of hot chocolate, I believe it was. If I pay $28 for 8 cups, I'm going to divide both of those by 8. You can see my work for that here. And I get $3.50 for 1 cup. Again, this is my unit rate because it is over 1. The most important part to remember for unit rates is they have to have a denominator equal to 1. That's the most important thing there. So, $34 per pound. That's $34 over 1 pound. This is a unit rate. 25 miles per hour. 25 miles over 1 hour. Again, that is a unit rate. 15 inches in 1 week. That's a unit rate because it was 15 inches of rain in 1 week. So, again, this is just how you would write a unit rate. A unit rate is a rate where the value of the second quantity is 1 unit. And we use these a lot in everyday life. If we go to the grocery store, we want to know how much the cost per pound is for grapes. So that's cost per pound. On the highway, we see a sign that says that the speed limit is 25 miles per hour. That's the speed limit. A lot of times you'll see this on the news, and it'll tell you guys how much it rained in 1 hour or in the season. And you could also get it as a 15 inches in 1 week. So express the ratio as a unit rate. 20 pencils for $5. Now let's not get confused here, and we don't want to know how much of a pencil we get for $1. We want to know how much each pencil cost. So money is going to go in the numerator, and the quantity of pencils is going to go in the denominator. This is it written as a rate first. So now we know we're doing 5 divided by 20. And 5 divided by 20 means it's 25 cents per pencil, or 25 cents over 1 pencil. So you could write that 25 cents per pencil, or you could also figure out this. I don't really like the answer 3 pencils per dollar, but you do see sales like that sometimes. I think this is more useful information. Both of these are unit rates, but this is the one that I would prefer you guys find and prefer you write it as. So here's a bunch of writing all over the screen. So 50 miles per 10 gallons means I can go 5 miles for 1 gallon. $5 for 10 pounds of potatoes means that it is 0.50 per pound. So it's 50 cents per pound. $55 for 5 hours of work. That's the rate. And that is the unit rate. $11 per hour. 500 miles in 5 days simplifies to be the unit rate 100 miles per day, that you went 100 miles over 1 day. 100 people in 4 rows means that there are 25 people in 1 row. 25 people in 1 row. 500 trees in 10 gardens means that there are 50 trees in 1 garden. So that is how we would do these. Again, this one right here would be written 50 over 100. 50 over 10. And then we can simplify that through the division and get 5 miles per gallon. Is how that would be written as a unit rate. Let's quickly move on to the next page. So let's see if you guys can get this one, and I'll show you the answer in just a second. Molly bought 128-ounce bottle of shampoo to save money. She used 8 ounces of shampoo per week. At this rate, how many weeks did the shampoo last? So the rate is going to be 128 over 8, right? So we're going to simplify it to be a unit rate. And now let's see, what does that simplify to equal? So it means that she can use the shampoo for 16 weeks at that rate. So let's move on to this one. So sometimes it'll ask you guys to compare two ratios or two rates. And before you can compare two ratios or compare two rates, they work just like fractions. We need to either find the unit rate or we need to find a common denominator. So for this one, I worked it out by finding the unit rate. So here it is. I've set it up $3.20 for 20 ounces, $2.52 for 18 ounces. I did 20 divided by 20 to get 1 ounce, and then $3.20 divided by 20 to get 16 cents. And I did the same thing here. So which one of these is the better buy? 14 cents per ounce is the better buy. So overall, it is 14 cents per ounce. You guys, these are called unit rates. You will see these in stores every day. A lot of times they like to be confusing though, and they'll tell one unit rate in like pounds and the other one in ounces. So you do have to do some conversions for that. These are just two examples of some kind of real life examples. There is a ratio. The reason that it's 14 karat gold, it's the ratio of how much gold to how much the chain weighs out of the 24 carats, which is pure gold. And again, here's another example of just a ratio. What is the difference between a ratio and a rate? Here you are comparing humans to humans. But as a rate, it is comparing different units like distance and time, like price and pound. Those are different types of units. These are the same types of units. So that is, again, this is a rate. This is a unit rate for that. So it is 40 cents for one muffin. "30 feet in 1 hour." So that is the end of the presentation. If you have any questions, send me a message. Otherwise, just think about what is the difference between rates and unit rates. Ratios are just a comparison. There are several ways to write those, and they do simplify just like fractions.